Alright guys, this is the start of section 7.3 video, and this section is all about how we can prove that a quadrilateral is a parallelogram. So before we knew it was a parallelogram, and therefore here are the properties. Now it's, we don't know that it's a parallelogram, so what kind of things can we do to say for sure whether or not it is? Okay, so there's 4 theorems here, and a few of them are converses of the last section, but not all. Okay, so one of the ways is the parallelogram opposite sides converse. Okay, so remember the converse is just when we flip the hypothesis and the conclusion. So this theorem tells us if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. Okay, so we don't need to know they're parallel. Just knowing that both pairs of opposite sides are congruent is enough to say that this is a parallelogram. Okay, and then we have the parallelogram opposite angles converse. Okay, and this tells us if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so we just flip the hypothesis and the conclusion of this from last section. If we know the opposite angles, both pairs of opposite angles, not just one, are congruent, then that's enough to show or to say that it is a parallelogram. All right, let's look at this picture right here. And hopefully you guys have all been to an amusement park and seen this little dragon thing that goes like back, forth, and then it goes higher and higher and higher, and eventually it goes all the way around. That's what this is. I couldn't do it. It would probably make me sick. An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back to forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms. So AD and BC. Okay, and DC is parallel to the ground. So DC is parallel, and let me go down. Yep, to the ground. So DC is parallel to the ground. Explain why the moving platform AB is always parallel to the ground. Okay, well, if I look at this, 16 and 16, 38 and 38. So I can immediately say that ABCD is a parallelogram by the parallelogram opposite sides converse theorem. Remember, if both pairs of opposite sides are congruent, then it's a parallelogram. So I know that this figure here is a parallelogram, okay? And because it's a parallelogram, I can go one step further and say, therefore, AB is always parallel to DC. Okay, so these 2 will be parallel because this is a parallelogram. But I know that DC is always parallel to the ground. Remember the transitive property of parallel lines? If one thing's parallel to another and to another and to another to another, they're all parallel. So therefore I can say that AB is parallel to L. So AB is parallel to the ground, which is why you don't see people flying out or falling off or whatever. It stays parallel to the ground all the way through. All right, I want you to look at example 2, and I want you to answer this question, and then we'll review it. All right, it says in quadrilateral WXYZ, angle W is 42, X is 136, Y is 42, Z we don't know. And we want to know, is this a parallelogram? Okay. Well, the only thing we know is true about all parallelograms is that their interior angles add to 360. So I can say 42 plus 136 plus 42, and I'm going to call this X because we don't know it, plus X equals 360. Okay, so 136 plus 42 plus 42, 220 plus 42, nope, I already did that, sorry, 220 plus x equals 360. Subtract 220. I have x equals 140. Okay, so angle Z is 140 degrees. Is this a parallelogram? Well, the answer is no, because Z and X are opposite angles, and my opposite angles are not congruent. Opposite angles are not congruent. All right, I want you guys to look at example 3 and try this one on your own. This one is not too difficult neither, and then we'll go over it. All right, so in order to make this a parallelogram, I know opposite sides have to be congruent. Okay, well, if I notice this side and this side have an x and a y. This side and this side both have an x, so I can go ahead and solve for x here. So they have to be congruent, meaning they have to be equal. So x plus 9 equals 2x minus 1. I'm going to subtract x from each side. I get 9 equals x minus 1. Add 1. 10 equals x. Okay, so 10 equals x. So now I've solved for x, but I still have to solve for y. So if 10 equals x, I can plug 10 in for x to know that this side is 17. Well, if this side is 17, the opposite side has to be the same, so y has to be 17 as well. All right, let's look at these two theorems here. All right, I'm actually going to skip this one and go to this one first. Okay, so the parallelogram diagonals converse. So we've seen this before. This is just a converse, so we flip the hypothesis and the conclusion. And it just says if the diagonals of the quadrilateral bisect each other, then it's a parallelogram. Okay, now this one here is the one that is always forgotten about. Okay, this one always left out. It's always forgotten about, and it is very, very important. Okay, so like highlight this, star it, do something in your notes to kind of divert your attention to look back at this before you take a test, because this is very important, and like I said, it's often forgotten about. Okay, so this one is not a converse. Okay, this is the opposite sides parallel and congruent theorem, which tells us that if one pair, so we only have one, pair of opposite sides in the quadrilateral are congruent and parallel, then it's a parallelogram. Okay, so all we need is one pair to be both congruent and parallel. See, like on this figure here, BC is congruent to 80, and it's also parallel, so we don't need to know anything about these other two sides. That's enough to say that these are that this is a parallelogram. All right, let's look at example 4. It says the doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how we know that SV is equal to TU. Okay, so we want to know, how is this equal to this? Well, if I look at this figure, I know that ST and VU are both parallel and congruent. Okay, I know they're both parallel because this arrow here and this arrow down here, and then I know they're congruent because this single hash mark and this single hash mark. So by the opposite sides parallel and congruent theorem, I can say that STUV is a parallelogram. And once again, that was by the opposite sides parallel and congruent figure. I have one pair of opposite sides that are both parallel and congruent. Okay, well, if this is a parallelogram, then I know that SV has to equal TU by the opposite sides, or I guess it's parallelogram, opposite sides theorem. That's one of the properties of a parallelogram is opposite sides are congruent. All right, so in example 5, notice we're looking at the diagonals here. So we're going to use the parallelogram diagonals converse, which basically says if both pairs of diagonals bisect each other, then it's a parallelogram. Well, I can look, and it's already given to me that FD bisects CE because these two are equal. So now all I need to show is that this here is equal to this here, which would mean that this is a parallelogram by the parallelogram diagonals converse theorem. So I need 5x minus 8 to be equal to 3x. Then do a little bit of algebra. Subtract 5x from both sides. I'm left with negative 8 equals negative 2x. Divide by negative 2. I get 4 equals x. Okay, well, that's all I needed. What is the value of x? X is 4. Problem solved. All right, I'm going to let you do example 6 on your own, and then we will go over it. All right, so in order to be a parallelogram, opposite angles have to be congruent. Okay, so A and C have to be congruent, and also B and D have to be congruent. So if they're congruent, that means they have the same measure, so they're equal in measure. So 3x minus 32 has to equal 2x. Subtract 3x from both sides. I have negative 32 equals negative x, or just 32 equals x. That's what my x has to be. Now my y has to be, so 4y equals y plus 87 minus y on both sides. I get 3y equals 87. If I divide both sides by 3, I get y equals 29. Problem solved. Guys, this is in your notes, and it's just a visual and along with words and theorems that kind of sum up this entire section on how to prove triangles are congruent. One thing we didn't talk about a lot is one way to prove it is by definition, is simply by showing that opposite sides are parallel. And then we had the 4 theorems that we learned along with that.